Hi, I'm Marty.
And I'm Beth. We're the hosts of STEM in 30, an Emmy-nominated television show for middle school students produced at the National Air and Space Museum.
Today's program is called What's New in Aerospace, and it doesn't get much newer than this. Right now, we are about 2 hours and 53 minutes away from a rover landing on Mars.
The National Air and Space Museum is not only home to some awesome air and space related artifacts, it is also home to an active research arm called the Center for Earth and Planetary Studies.
And today we're going to introduce you to two of our scientists who will be answering your questions.
Throughout the program today, we want you to ask our experts questions.
Bonus points if you can stump them.
And we also want to know where you're watching from. Put it in the comment section and we'll try and give you a shout out.
We're also going to be sharing some additional resources for you to learn more about Mars and the upcoming landing.
The first resource we want to share is from our most recent episode of STEM in 30 called Perseverance, What It Takes to Land on the Red Planet.
Here is a small piece of that episode. Check it out.
On July 30th, the Mars 2020 mission was ready to go.
Right, and liftoff.
The spacecraft lifted off the pad at Cape Canaveral, Florida, and began its nearly 7-month journey to the Red Planet. On February 18th, we will begin entry, descent, and landing. Every part of this is autonomous. No human is controlling the landing. Even though the atmosphere is thinner on Mars, entry is still hot and dangerous. The capsule has to turn to an entry attitude, turning the heat shield to enter the atmosphere safely. Once we're inside the atmosphere, then the parachute is deployed. This slows things down a lot more. The heat shield is released. The surface of Mars is approaching quickly. Then the back shell and parachute is jettisoned, and retro rockets fire. The camera searches for the correct place to touch down. Once ready, the sky crane activates, lowering the rover to the ground. Once sensors indicate that the rover is safely on the surface, the descent stage separates and does a flyaway, crash landing far away from the rover. And here we are on Mars.
Now we are joined by two of our planetary scientists, Dr. Mariah Baker and Dr. John Grant. Thank you so much for joining us today.
Thanks for having us.
All right, we know that we're getting close to, we know we're getting close to landing on Mars. My count says about 2 hours and 50 minutes away. Mariah, you are a member of the Perseverance science team. What's happening right now?
A lot of excitement, a lot of nerves. The spacecraft is finishing up its 7-month journey to the Red Planet. It's traveled over 200 million miles, and it's got about, I think, less than 100,000 left to go, which sounds like a lot, but it's traveling pretty quickly still, about 40,000 miles per hour. So in a couple short hours, it'll be arriving at Mars, and we've been monitoring it as it has been traveling to Mars and through its cruise stage and through the approach. There have been a couple opportunities in the last few weeks to make some final adjustments to the trajectory, and everything seems to be working as it's supposed to. So we're looking forward to entering, descent, and landing.
John, it's getting a little busy around Mars these days. It's not just Perseverance. Do you want to tell us what else is going on up there?
Oh, it looks like
so. Just in the past week and a half or so, we've had 2 additional spacecraft enter orbit around Mars. One from the United.
Well, it looks like John's having some internet trouble.
Mission looking in the atmosphere of Mars. Whereas the China mission is one that will separate a lander and eventually touch down on the surface.
All right. Mariah, why do they call this the 7 minutes of terror?
Yeah, so the 7 minutes of terror refers to the 7 minutes it takes the spacecraft to descend from the top of the atmosphere down to the surface. So this is a really exciting time of the mission. It's the rover needs to slow down from about 12,000 miles per hour to 0 to get to stationary at the surface. And one of the things that's particularly terrifying about EDL, entry, descent, and landing, is that it's done entirely autonomously. So there's no human intervention. The rover is on its own. Everything has been pre-programmed. And because the communication time between Earth and Mars right now is about 11 minutes, by the time we get word here on Earth that the rover has entered the atmosphere, in reality, it has already landed on the surface one way or the other. So we're sort of just sitting back and hoping that the spacecraft does what it's designed to do.
If you all have questions, we want to hear from you. Put them in the comment section, or you can tweet us at STEMin30. You can even email us at STEMin30@si.edu. We'll try and get to as many questions as we can. Be sure again to tell us where you're watching from, and we'll try and give you a shout out.
Speaking of shout outs, we have got a whole bunch of folks tuning in. We've got Missouri, Oklahoma, the Netherlands, California, New York, Idaho, Indiana, Florida, Texas, Oklahoma, Pennsylvania, Emerson Elementary School, Carolina Forest International Elementary in Jacksonville, North Carolina, Italy, New Jersey, homeschoolers from Houston, Texas, and Washington, all tuning in. Thank you all so much for watching. Keep those locations coming in and the questions.
Our first question is from our email account, and someone would like to know, how long does it take to build a Mars rover?
It's a great question. I'll go ahead and take this one. It takes a very long time. In fact, the beginning of the Perseverance mission started back when Curiosity landed about 10 years ago. So it's been almost a decade of preparation of this. Here on Earth, we've got to, there are a lot of steps that need to happen before we launch off the surface. The instruments need to all be designed, calibrated, tested in Mars-like conditions, and then they all need to be incorporated into the spacecraft body. And all of that takes years of preparation. And then we launch off the surface and head to Mars, and then the real fun begins.
All right, Mariah, our next question coming in, or John, either one, will the rover be returned to Earth? And I know we've got some curators in the Space History Department that would love to have that rover on display. Is it coming back? John, if you got us, is the rover coming back? If not, Mariah, go ahead and jump in.
Okay, I was giving John a second to maybe get into it. I don't know of any plans to bring the rover back. We've landed a number of spacecraft on the surface, and once their surface missions have been completed, they're still there, accumulating dust and keeping each other company. Bringing a spacecraft back would be a big ordeal. We are, however, going to hopefully be bringing some samples of Mars rocks and soil back in the next decade or so. And that's actually starting with this mission. So Mars 2020 is starting what's known as the Mars Sample Return Campaign. And so one of the major goals of the mission is to drill and collect material that the rover will leave in small tubes on the surface for a subsequent rover to come and pick up, and then that will be launched off the surface and given to another spacecraft that will return those to Earth. So it's sort of an interplanetary relay race. But so we will get something back from this mission. I just don't know if it's the rover itself.
We've got a lot of people watching from all over: Alaska, Belgium, Georgia, Virginia, Detroit, Louisiana, Scotland, Boston, Peru, Canada, Barcelona, Hive 20 from Biomed Science Academy in Ohio, Iowa, Oregon, and Maryland. Thank you so much for watching. Our next question is, and Mariah, I know that you've been working with this team, so maybe you can answer this. Will we be able to see camera footage from the rover? Cameron, who's in 4th grade, would like to know.
Yes, absolutely. We've got a number of cameras on board, and actually some of them will be filming during the descent. And so we're not going to get those back in live time, but at some point we will be able to watch the descent as the rover saw it. And then we've got a number of cameras on board, as I said, that will take images of the surface, and we even have one that has movie capabilities, which is something that's new for this mission and is super exciting for someone like me who studies things that move on the surface, because we actually can capture that in action. So we'll get a lot of great images. We've got similar cameras to what we had on the Curiosity rover, which has returned really stunning images from the Martian surface. So you should be expecting to see lots of great images of Mars soon.
Awesome. I can't wait. And we are about 2 hours and 43 minutes away from landing. And as soon as we're done with the live chat, we'll hand it off to the NASA TV coverage. So that's coming up here at about 2:15 Eastern time. So make sure you stay watching for that, because there's going to be all kinds of great stuff coming out today. We've got another question that came in. Are there any science packages on the Sky Crane that will survive the impact?
Great question. I do not know of any. It makes a pretty hard landing on the surface, so I don't think that anything could survive that. The Sky Crane's real purpose is to get that rover down to the surface safely, and hopefully that will be achieved. And if it crash lands somewhere far away, that's the goal.
We have our next question is. How does the Mars rover communicate information back to us on planet Earth? This is from it's an email from a homeschooler. I'm not sure if I know that John is having some issues with the internet. So let's, if John can answer, that's great. If not, Mariah, we'll let you take that one as well.
See if John can catch up, maybe.
I think we're trying to get John in another way. So Mariah, go ahead and we'll get John back here.
Okay, absolutely. And I'm so sorry. I have actually totally forgotten the question.
The question is, how does the Mars rover communicate information back to us on planet Earth?
Yes, absolutely.
And it doesn't take just a second. It takes a while, doesn't it?
It does take a while. So as I said, there is a delay in the time that the rover collects information and when it can get back to Earth. It depends on how far the planets are from each other. The rover has a couple antennas on board. And so technically, those antennas can send information directly back to Earth. But when we're doing sort of normal surface operations, we often have a lot of data that we're trying to transmit. So we often use the orbiters that are around Mars to transmit information back. So the orbiters that we've got in around the planet can cross over where the rovers are on the surface, and they can transmit information to one another. And then the orbiter can send that information back to through the Deep Space Network to antennas here on Earth, and then that gets transmitted to JPL. So it does take a little bit of time, and sometimes when we call into planning on any given day, sometimes you can watch the data trickle in as you're sitting there. It takes a bit of time, but we've got sort of a system in place that allows us to get that data back as soon as possible.
Awesome. Well, we've got folks tuning in from all around the world. We've got Hawaii, homeschoolers in Gulf Shores, Alabama, South Carolina, Colorado, Illinois, Amsterdam, Tasmania in Australia, England, Slovakia, Chile, New York, West Virginia, Brazil, Ontario. Thank you all so much for tuning in. We really appreciate it. Mariah or John, it looks like we've got John back now. We've got a question here from Elise in Scotland. How likely is a Perseverance rover to help with human missions to Mars? Mariah, you want to take that one?
Yep. Yeah, I got it. So one of the primary mission goals actually is to help prepare for human exploration. And this is a part of the mission that I'm particularly excited about. All prior robotic missions have been sort of paving the way for humans. We send robots to the surface to scope out what's there, test the environment, see what humans would have to work with and would have to deal with on the surface. And so that's sort of a precursor to sending humans. But this mission in particular is actually really going to make that happen. There's an interesting new instrument on board called the MOXIE instrument. And what this instrument does is it takes in the atmosphere, the carbon dioxide atmosphere on Mars, and it tries to turn it into oxygen that can be used by astronauts on the surface and can be turned into propellant to launch back off the surface. So human missions are really on the horizon, but they do require a lot of planning. And in order to decrease the amount of material we'd have to bring from Earth to Mars to sustain these astronauts on the surface, it's important to try and figure out how we can use the resources provided by Mars and by the atmosphere and by the rocks, how we can use those to our advantage to decrease the amount of material we have to bring from Earth. So MOXIE is one of those instruments. Another one is RIMFAX. This is the first ground-penetrating radar being sent to the surface of Mars. And RIMFAX and other radar instruments could identify subsurface ice that might be able to be accessed and used by astronauts on the surface. So that's another one. This is all falls under the category of what's called in situ resource utilization. So ISRU, these are potential ISRU instruments that can really enable human exploration of Mars in the future.
We've got a lot more people from watching all over the world. Moscow, Augustine, Florida, Middle Creek Academy, Ecuador, students at Sussex Charter School, Empire High School in Tucson, Arizona, Oregon, Colombia, United Arab Emirates, homeschoolers in Toronto and Alberta, Puerto Rico, United Kingdom. Our next question, Mariah, is how many rovers are there right now on Mars?
That's a great question. So Perseverance will be the 5th. It started with Sojourner, who was a technology demonstration actually on the Mars Pathfinder mission. And I heard John refer to it in the Smithsonian Channel documentary the other day as a microwave on wheels. It was a very small rover, and it was basically sent there to test out whether we could rove on the surface. And it was successful. It didn't travel very far. I think it only got like tens of meters away from Mars Pathfinder, but it proved that we could do that. And so then subsequently we sent the Mars exploration rovers, Spirit and Opportunity, and then the Curiosity rover, and now Perseverance. So, and they've gotten progressively larger over time. So we've got a couple roving objects now on the surface.
All right, well, the weather here near Washington, D.C. is not good today. We've had sleet all morning and it's starting to pile up and snow's coming in later, but it's a beautiful day for a landing on Mars. And we've got some students in Virginia who are learning about Mars on their snow day. Thank you all for joining us. We've also got the Navajo Nation in Arizona, Westmount Public Schools, Laurel Hill Primary first grade class in South Carolina, as well as the Netherlands tuning in. So thank you all so much for tuning in. And be sure to let us know what questions you have down in the comment section on Facebook. You can give STEM in 30 a follow on Twitter and submit a question there. Also, you can go to the website and follow us there as well. So, Mariah, we've got another question that's come in. How long will Perseverance operate, and what happens once it shuts down?
Yeah, another great question. I think the nominal mission is at least one Mars year. But we've seen in previous missions that these missions end up lasting a lot longer than they were designed for. I think Opportunity was planning for a 90-day, 90-sol mission and lasted 15 years. And the battery power on the rover can last up to 14 years, I think. So it could be much longer, and hopefully it will be much longer than that one Martian year, which is about 2 Earth years. But that's sort of the nominal mission. And once it's done, hopefully it has placed samples, a little Easter egg hunt on the surface for the next rover. And then it'll just stay there in Jezero Crater or possibly outside, depending on how far we get in our traverse. But it'll wait there until the subsequent rover comes and picks up those samples that it cached.
Mariah, you were talking about samples, and we've got a question from Facebook, and they would like to know, what are you going to be looking for in the samples that you collect?
This is a great question, and something that's been discussed a lot on the team, and will continue to be discussed as we kind of see what's on the surface and actually get a sense of what we will be able to bring back. We've got about 30 sample tubes, I think, so we've got a good amount of things that we can bring back, but we're looking for a diversity in samples, a diversity in rocks. One of the primary mission goals is to search for ancient signs of life, and so we're particularly interested in getting samples from this delta that's preserved on the surface where water used to flow. And so taking samples of that rock, of those rocks, and bringing them back and sampling them in, testing them in laboratories here on Earth, where we've got a lot more instruments, and where maybe 10, 15 years down the line, we've got new instruments that we can't use today. We will be looking for signs of ancient life in those samples, and we'll also be testing the mineralogy. There's a lot to learn from them, and also for human exploration, we'll be looking for if there's any kind of hazardous material in the soils. There's often been thoughts that Martian soil has what's known as perchlorate, which is potentially poisonous for human astronauts. So things like that are going to be really interesting to look at. Also looking at the composition of dust, which is pervasive across Mars. There's lots to be studied, but deciding exactly which rocks to sample and which to pass on is going to be a really, really interesting thing for the team to have to decide and work together to figure out the best set of samples to send back to Earth.
All right, well, we've got folks tuning in from the Dominican Republic, Casablanca, Morocco, Denmark, South Africa, Cyprus, the Arizona Science Center, Edwin Parr Composite High School, and homeschoolers in Alaska. Thank you all so much for tuning in. Let us know where you're watching from, and we'll try to give you some shout outs throughout the rest of the show. Again, we are going right up until NASA TV takes over the coverage at about 2:15 Eastern time. Mariah, we've got another question that's come in that I had never thought about before, and I think this is a really cool question. Can the previous rovers communicate with each other or with Perseverance once it gets there?
That's a great question. I've never thought of that either. I don't know. I think you'd have to ask the engineers. I think theoretically it seems like it could be possible. They are pretty far away from one another. So whether or not they'd be able to communicate directly, I don't know. But whoever sent that question in should look it up and tell us the answer sometime.
Well, congratulations. You actually stumped our expert, and we love that here at the National Air and Space Museum. We've got people watching from Mexico City, Walden Public Schools in Canada, South Dakota, Alberta, Maine, Iran, and India. And our next question, somebody from Costa Rica would like to know, how will this rover's exploration be different from past ones?
A great question. So there's a couple things that distinguish it. Every mission that we do on the surface is different and has kind of different primary science objectives. The Mars 2020 rover will be in a particularly interesting place on the surface, in Jezero Crater, where we know there was this intercrater lake. There is a delta and an inflow channel on the west, and then an outflow channel on the east. So we know that it was a really dynamic system, and one that has the potential to actually maybe host life in the past. So this location is something that really distinguishes the mission. And then I also think the payload that's included on the spacecraft is really something new. And even though you might, just looking at it, think it looks pretty similar to Curiosity, and some of the instruments have definitely been adapted from what we have on the Curiosity rover. A lot of instruments are totally new and things that we've never tested before. The Ingenuity helicopter, which the rover is bringing along with it, is a technology demonstration, is going to be trying to do the first powered flights on another planet. And so this will be happening pretty shortly into the mission. So this is entirely new, and we're really eager to see how this thing flies. Flying a helicopter on Mars is not an easy thing. And so we'll be paying close attention to that. But I think there's a lot of new stuff that's going to happen with this mission. So stay tuned.
So exciting. And we are about 2.5 hours away from landing. We've got about 40 minutes left in this live chat. So please put those questions down in the comments, or at STEMN30 on Twitter, or email us as well. And we will get to as many of them as we can. Mariah, the next question that comes in is, if we find evidence of life on Mars, then what?
Great question. Well, that would be incredibly exciting, and I think that it would give us another direction to go in our exploration of the planet if we finally kind of find life on the surface. There's going to be a lot of planning, I'm sure, that then goes into things that something that's called planetary protection, which is making sure that anything we bring back to Earth isn't going to contaminate the species here and bring back something harmful. And the other way around, we want to make sure that we didn't accidentally bring anything to Mars that then looks like life on the surface. And so we'd want to make sure that it was real and organic life that formed on the surface of Mars. And then we would dive into how did it get there? Where is it? What kind of life form does it seem to be? I'm not an astrobiologist, so I probably won't be answering those questions, but I'm sure there will be a lot of work that goes in if a discovery like that was made.
All right. Well, we're talking about a rover that's millions of miles away on Mars and communicating with it. And our communication's been a little spotty today, but I think we have John Grant back. John, are you there? All right, we've got John back.
I think my internet is not as reliable as the one from Mars.
Well, John, we're glad to have you back. How excited are you about this landing?
I'm very excited. This is something that only happens every 7 or 8 years in terms of landing on Mars. And I think, as Mariah has done a wonderful job of pointing out, we're really on the threshold of starting to understand whether or not there actually could be life on Mars, or has been in the past. So this is something that's got a lot of people's interest.
So I want to point out that we still have a lot of people watching from all over: Dubai, Norway, homeschoolers in Wisconsin, California, Budapest, Hungary. Let's ask John, since you're back, the McNally family from St. Louis, Missouri. How soon after the rover lands will they launch the helicopter?
Well, once the rover's down on the surface, there's a lot of sort of checkout and testing that needs to be done to make sure that everything survived the landing. So it won't be in the next day or two. It'll be a little bit down the road. But I'm pretty sure, given all the excitement and interest, that when that is about to happen, everyone will know about it. So you'll have an opportunity to tune in.
And I'll add to that it should be pretty early in the mission, because it's not easy for the rover to drive around with a helicopter attached to its underside. So it shouldn't be too long before we have to wait to see those happen.
I can't wait to see those. We've got a fourth grader doing online learning that says they're so ready to see the landing. What's the best way to keep following it? And I know that we can pull up the NASA website that has the countdown to landing on there. You can head over to the NASA website. We will be live here until about 2:15, and then NASA TV will take over that coverage. And the rover touches down at 3:55 Eastern time, which is about 2 hours and 26 minutes away. John, another question that has come in: how and where is the rover tested before being sent to Mars?
Well, it's tested where they assemble it out at the Jet Propulsion Lab. And then there's a final checkout process that occurred down in Florida at the Kennedy Space Center before launch. But many of the components are actually tested as they're being designed, like the parachute and other things are checked out in various locations before they're actually assembled into the completed rover. This is truly a group effort. There are many, many different people that have come together and provided various components of this rover to make something that, once it's all together, gets at these questions of whether or not there could have been life on Mars.
A next question we have, and I'm going to throw this at John again, because I know we've discussed it.
Give Mariah a break.
Yeah, you can catch your breath. What made this landing site in Jezero so promising? What is it about that area, and how did we choose it?
Okay, well, I'll start with the second part of that first. We actually had a very long and involved process, about 5 years long, where approximately 30 different candidate landing sites were considered not only by the science team who makes the ultimate recommendation to NASA and who picks the site, but also by the science community. They brought everybody in and said, if you were going to go with one place to try to bring samples back to try to find out if there's life on Mars, where would you go? And we whittled down that list and arrived at the Jezero crater site, by and large, because there is a large river delta that we see entering from a valley that cut through the western rim of the crater that you can see here in this image. And the circle, which is the landing site for Perseverance, is kind of right on the edge of that delta. And what's important is that the sediments that were carried down in that river were deposited out on the floor of the crater, and then that delta grew out across it and sort of preserved them. And what we call the bottom set beds, the layers of sediment that are right at the base of the delta, that were in a lake that were before the delta grew out across it, are the place that we might be able to preserve, if they were ever present, the kind of biosignatures that would let us say something about past life on Mars. So Jezero is really unique in that sense, that it's got this well-preserved delta, these access to these kinds of layers of sediment that we think can answer those questions.
Awesome. Well, we've got folks tuning in from Germany, Sweden, Cumberland Valley Virtual Academy, Saudi Arabia, and the Philippines, where it's 2 a.m. Thank you all for tuning in. And the fact that I keep coming back to that kind of blows my mind is that right now, until we discover life, Mars is the only planet we know of completely inhabited by robots.
And we mentioned earlier that we're going to share some resources with you today so you can learn more about Mars and the fleet of robotic explorers we have sent to the Red Planet.
STEM in 30 has produced a lot of videos on Mars, and we've created a Mars playlist on YouTube. There you will find a whole bunch of videos about Mars, including interviews with experts, animations, and astronauts telling about future journeys to Mars.
Our friends at the Smithsonian Channel have also created a couple of amazing resources. The first is Making Tracks on Mars, the Smithsonian Channel's mission critical special that goes into detail about the entire Mars 2020 mission.
Drawing on the resources and research that went into this special, they have created Mars AR, an augmented reality experience. This thing is cool. Interact with Percy and its rover predecessors, and even drive the rover and fly the new Mars helicopter.
So we have still got a lot of people watching, a lot of questions coming in. We've got people in Spain, Argentina, Trinidad, Guantanamo Bay Naval Base, Serbia, Poland, France, Colorado, and homeschoolers in California. Our next question is, what happens if something goes wrong in the entry, descent, and landing system? Are there any backup plans for that?
I don't think either one of us wants to take that one. No, there is no backup parachute. There is no backup sky crane. But I think your earlier question about the testing that goes on and the design that goes into this instills a sense of confidence that this is a very robust landing system, or as we say, entry, descent, and landing system. And let's not forget that the Curiosity rover, which is operating on Mars, used a very similar process for getting down on the surface. So we do have that sort of heritage to draw on.
All right, well, we've got folks watching from all over the place. If we haven't given you a shout out yet, be sure to let us know where you're watching from. You can either let us know in the comments section on Facebook or at STEMin30 on Twitter, or email us STEMin30@si.edu. And we'd love to know where you're watching from and what questions you have for Mariah and John. And our next question comes in. They want to know, how is Perseverance and Ingenuity situated? Or is Ingenuity on top? Is it at the back? Where is it?
Yeah, so Ingenuity is kind of right underneath the rover. They made it very small, I think, for that reason, and because it's hard to fly in the thin Martian atmosphere. So it's only a couple pounds, I think, 6 pounds, but it's sort of situated underneath the rover, and the rover will drop it off on the surface and then drive away, and then the helicopter will try to take flight.
We've got Avery from Connecticut, and this is a question that both of you can answer. Avery would like to know, do you have a favorite part of the rover, and what is it and why? So let's start with John since he's laughing.
You know, my involvement in some of these rover missions goes back to the spirit and opportunity, and I think that my favorite part would be the mast and the cameras up on top, because after you've worked with these for a while, you start to almost see them as living beings. And to me, those are sort of, that even though the brains are kind of down inside the rover, when you look at the rover, that kind of looks like the eyes and head. And to me, that's the sort of part of the rover that's most lifelike.
What about you, Mariah?
Yeah, there's so many great instruments on board. I think I'd have to say one of my favorites is definitely that MOXIE instrument that I was mentioning before. This is an entirely new instrument, and it's really trying to pave the way for human exploration by turning the atmosphere into something that we can really use. And so I think that that's an incredibly useful thing, and is really innovative, and it's going to be exciting to see how the MOXIE experiments go. I think the other one is the meteorological sensor, which I'm biased. I use that sensor for data for my studies, and so it's one of my favorites for that reason. But it's really important that we understand the environment on the surface, and so the META instrument, it provides information on the temperature, on wind, on pressure, things like that will also help prepare for human exploration by telling us what the surface conditions are and what the environment is like, and how these things change over the course of the year. And so it's a dynamic system, and META helps us understand that.
Awesome. Well, we know we've got a lot of schools watching today. Thanks so much for tuning in. We'll go up until about 2:10 today, and then the NASA coverage starts at 2:15. So make sure that you're watching NASA TV when their coverage starts. We've got Mrs. DeSalvo's 4th grade class in Temecula, California watching. And this question, I think, follows up on all of these schools that are watching. From Macon, Georgia, they wanted both of you to talk a little bit about your educational background and what do you have to study to start working on Mars? Mariah, let's start with you.
Yeah, so I grew up in Boston and went to Brookline High School, and was always sort of interested in math and science, but didn't quite know how that would play out moving forward. When I went to undergrad, to college, I studied astrophysics, and so that's how I sort of got into the space field. And then after that, I sort of decided I loved space, and I loved studying space, but I wanted to do something a little closer to home. And so Mars was sort of that happy medium where I was working in space exploration and getting to work on space missions, but studying an object that was closer and that we could actually touch and see. And so it was sort of that happy medium. I think there are a lot of great things, a lot of different types of things that you can do to get involved in planetary science. I mean, we have a lot of different disciplines that are represented on the team. People that study astrobiology, geologists, atmospheric scientists, all sorts of different things. And so it's really about finding what you're passionate about and pursuing that.
John, how about you?
I grew up in far northern New York, a town called Plattsburgh, and there's a big lake up there called Lake Champlain, and growing up along the shores of that lake, it was a wonderful opportunity to learn about the landscape, to learn about the rocks and how water shapes the landscape. And so when I went on from high school to college, I went into a geology program and learned about how the world and the earth have evolved over time. When I went on to graduate school, I worked with a man that had a small grant doing work related to mapping a portion of Mars. And I kind of scratched my head and said, I had no idea that you could do this sort of thing. And that was sort of the switch that got turned on. I helped him with his map. I went on then and got my PhD. But like Mariah, I would echo that a very important component is the math and science that allows you to build on the information that you're seeing in the landscape around you and provide you with the tools to interpret how it has evolved over time. So I think it's a kind of parallel track to what Mariah took, but there's little differences. And I guess what I would point out is while I took a track that was largely in geology. And Mariah, I think she's being modest. She's got a degree in astrophysics, but she's also very interested in how the wind shapes the landscape around her. Yet through these various backgrounds, we've all come together and work on the same projects together. So you can come at this from a variety of different angles, but I think the core is a strong basis in math and science.
As a former teacher, I love hearing what you both said. And Mariah, you mentioned following your passion. And one of the things that Beth and I have gotten to do while working on STEM in 30 is talk to some incredible people. And one of the things that they always say is to follow that passion, whatever it is. And during the broadcast today, you've seen some amazing NASA animations, and those are done by people that their passion is animating and making computer graphics. And there's got to be people that make the food for the astronauts on the space station. So whatever your passion is, follow it, and you're going to be happy no matter where you end up. And I think Mariah and John are great examples of that.
We've got still a lot of people watching from all over: Switzerland, Belize, Ireland. Federal public defenders are watching in Philadelphia. So that just goes to show you the wide variety of people who are interested in the Perseverance landing today. We have another question from Miller Middle School in California. They would like to know, how does the nuclear reactor on the rover work? And how does it power the gadgets on board? And the other thing I'd like you all to discuss is the difference between nuclear power is kind of new for these. We were using solar power, and maybe why did we switch?
Mariah, you want to take the first and I'll take the second?
Yeah, sure. So we have on board what's known as an RTG, radioisotope thermal generator, I think. And so basically we've got plutonium on board that decays into electricity that we can use to power the instruments. And yeah, as you said, we've also used solar panels before, and so maybe John can go into that. He worked on the MER rovers, which use those as well.
Yeah. So with solar power, obviously you're depending on the sun shining on the solar panels to provide you with the electricity. And one of the things that we know about the environment on Mars is it's dusty, and at certain times of the year it's quite a lot dustier than others. And you can see a picture now of one of the Mars exploration rovers. This is actually when it's looking fairly clean. So over time, as dust builds up, the amount of power that we get is reduced. With the Mars exploration rovers, it turned out that we got very lucky. Whirling sort of dervishes in the atmosphere called dust devils would come along every so often and blow off a lot of the dust, and we'd get that new rover smell back again, and a lot of power. The InSight lander, which is still operating on Mars as we speak, also has solar panels. And there is dust that's been building up on those solar panels over time as well. We haven't been fortunate enough to have a large enough dust devil come by to sweep the dust off there. So both kind of power sources are being used. I think there's advantages and disadvantages to both. It really comes down to the kind of mission you're doing. Do you need to do things at a higher latitude where the sun may not be shining as much during part of the year, those sorts of things.
Awesome. Well, we are about 2 hours and 11 minutes away from the Perseverance rover touching down on the surface. And we've got Sophie from Spain wants to know, how fast are the rovers and how do they compare to the other ones? Are they doing wheelies on the surface?
John, you want to take that?
Sure. You know what? Strangely, they can kind of do wheelies on the surface. And by that, I mean, you can actually lock up some of the wheels and then turn the other ones and sort of lift, they're all sort of an independent independently driven. You can actually kind of pop one up or something. Having said that, if you were walking on Mars, you would very, very quickly go right beyond the rovers. They're not moving that fast across the surface. To give you some sense, if there's no obstacles in the way that we have to go around, a really good day of driving on Mars is on the order of 150 to 200 meters. So somewhere on the order of 1.5 to 2 football fields. To give you a sense of the distances that we can go in a single day.
And just to add to that, one of the new things that Mars 2020 has is that it's got some new technology that's going to allow it to drive autonomously a little bit further than Curiosity has been able to in a given drive. So even though they're moving pretty slowly, hopefully we'll be able to make a little bit more progress each day.
To follow up on that question, somebody has asked, what's the difference in the wheels of this rover? Now, I know that there were some changes because we've learned some things from past rovers. John, do you want to tell us a little bit about that?
Sure. When we landed on the surface with Curiosity, the landscape around us has a lot of rock fragments on it. And the wheels, which have held up very well, we started to see after a time that there was some damage to them from driving over these sharp, pointy rocks. What that did basically is resulted in a little bit of a change in strategy, whereas before we might try to necessarily go straightest distance between two lines. Now we would go around things that look like they could damage the wheels. Here we are, something like approaching 8 years into the mission, and the wheels are holding up fine, and it looks like it's not going to be something that impedes us. But having said that, the wheels on Perseverance are designed to be a lot more durable, to withstand those kinds of pointy rocks that were doing a little damage to the wheels on Curiosity. So the sense is that they're going to hold up quite a lot better on Perseverance than they have on Curiosity. Again, though Curiosity has not been handicapped by the damage that's been occurring.
All right, well, we've still got people tuning in. Please submit those questions to us. We've got Greece, Serbia, the UK, North Macedonia, Scotland, Texas, Hawaii again, Arizona, France, Mallard Creek STEM Academy, and homeschoolers in Oklahoma. Thank you all for tuning in. We do really appreciate it. Our next question that came in is from a 12-year-old, and he wants to know if there are plans to send rovers to other planets and which ones. And I'd love to know which planets you all would love to send rovers to.
Yeah, absolutely. So there's currently the Dragonfly mission is in progress. This mission's going to send a robotic rotorcraft to Saturn's moon Titan in the next decade. So this will be sort of a step up from the helicopter that we're flying on Mars. This is going to be a full rover that can fly on the surface of Titan. And actually, I think that because Titan has a smaller gravity, lower gravity than Earth, but a similar atmosphere, it's actually a good place to fly. And so we designed this mission specifically to take advantage of that environment. And I've heard before, actually, that if a human was standing on the surface of Titan and flapped their arms, they could fly as well. So it's a really cool place to be, and definitely a place that I'm excited to send a spacecraft to.
John, where would you like to send a rover?
Mars. I'm a Marsophile, and I can think of lots of places where I would like to go. But having said that, there are different ways to do things, as Mariah was just describing, on the different bodies in our solar system. With asteroids and relatively small bodies, in addition, if there's no atmosphere, you might be able to use something called a hopper, where because the gravity is so low, you can kind of bounce around on the surface. Of course, there have been a variety of rovers on the moon. There's been some by different countries. There's been very recently rovers from China. And of course, in the past with Apollo, we had kind of car-sized rovers that drove around the astronauts. So I think that kind of thing is pretty cool. I would love to see a rover that could carry people. And hopefully that's coming in the not too distant future on Mars. So I can think of lots of different places, but I keep kind of circling back to Mars. I'm a little biased.
We still have a lot of people watching. Keep those questions coming. We have Gladys Young Elementary in Bethel, Alaska. People from Idaho, Vermont, Woodbury Central High in Iowa, Pakistan, my hometown, Memphis, Tennessee, Creekside Academy in North Carolina. We've got some scouts watching in Oxfordshire, UK, doing a project on the landing. Connecticut, Mr. Christian's history class in Jack London High School, Guam and Nepal. And we have had an email in from a woman in Kentucky, and her children would like to know, how do you name the rovers? John, do you just pick them out of the hat as a group of scientists, or is there a process there?
No, there's a process there, and I think probably some of the people that are online listening right now know about that process. The rovers have been named by students providing essays that suggest a name and why they think that name is appropriate. And a young man in Virginia is responsible for the name Perseverance that was given.
And if you want to learn more about the naming of the rover, and Alex Mather, who was the kid that submitted that name, our friend Jayden Jefferson did an interview with him. You can head over to STEM in 30 social media or the Air and Space YouTube channel and check that interview out. And they go into how he chose that name and why it's so appropriate. We've got a question from Ron in Menlo Park, California. He wants to know, I heard something about ground penetrating radar, RIMFAX on Perseverance. What are they really hoping to find with that?
Do you want me to take that?
Sure, whichever you want.
The instrument is called RIMFAX, and it uses a radar signal, a radio signal, to penetrate down into the subsurface. And when there's a change in the properties of the rock, either a difference between layers or composition, some of that energy is reflected back up to the rover, and it allows you to build up a picture of what the layers and the structure, the cracks, those sorts of things look like in the subsurface. In the case of RIMFAX, we hope to be seeing down, on order of up to 30 feet or so. And if there were ice in the subsurface, or water, we could probably see those as well, although those are not expected at the Jezero crater landing site. What's really important about that is as you drive along the surface, as you walk outside your house, you'll notice that there's not necessarily just flat-lying rocks and outcrops, as we call them, everywhere. There's trees growing, you have lawn, there's streets, and that covers up a lot of the rocks and precludes you from really seeing how those different places where you can see the rock actually match up with one another. And getting what we call context to be able to match up those different outcrops of rock allows us to piece together a much more precise sort of understanding of how the landscape has evolved over time. So RIMFAX really allows us to go from outcrop to outcrop and connect those up with a three-dimensional picture that we get from imaging into the subsurface.
Our next question is about looking for life on Mars. If we don't find any this time around, any evidence at all, are we going to keep searching, or at some point do you think we'll just say, okay, well, there wasn't ever any life on Mars?
I think that we will continue the search. Humans tend to enjoy exploring the solar system and figuring out our place in the universe. And to answer those kind of big questions about whether or not we are alone and whether Earth is really unique, we need to continue searching for signs of life. It's very difficult to search for life on Mars, and we only have these small. You're sort of looking for a needle in a haystack, and every time we land, we're in a new location, and we can search that location. But there are a lot of locations on Mars. We've got a lot of ground to cover, and so even if it doesn't, we don't find evidence of it here at Jezero, that doesn't mean it doesn't exist somewhere else on the surface. And as I said before with Mars sample return, that will help us really determine whether or not there was potential for life there back with instruments here on Earth.
All right, well, we are just about 2 hours from Perseverance landing on Mars. And this next question I absolutely love. Are there any cool Easter eggs or fun details hidden on the rover? Mariah, what can you tell us? What should we look for?
Gosh, that's a good question. I don't know about any Easter eggs. I know that there was a plaque put on in commemoration of COVID victims, and so that was sort of a late addition to, and I think also to the healthcare workers that have been leading the way in fighting this pandemic. And so that was sort of a late addition to the spacecraft and was put on there. I think there was also a list of names that people could submit their names, and that got added to the spacecraft as well. But I don't know about any other Easter eggs to look for.
If you find one while you're watching the coverage today, tweet it to us or go back and put it in the comments section or email. We would love to know if you find any. Now, John, there was an Easter egg on previous rovers on the tires, right? With the dots?
Yeah. So when you say Easter egg, I think about something that you're going to go out and find that's got pretty designs and the way I used to make them were green and blue and that sort of thing that you would put in a basket. But there are things that are there, and sometimes the tracks that you leave behind also give a little information as well.
Awesome.
John, someone would like to know if Perseverance will sing a birthday song to itself in the same way that Curiosity did, and if you want to talk a little bit about why Curiosity would sing itself the birthday song.
Well, we all like to have a birthday song sung to us. It makes us feel wanted. And if you're Curiosity and you're all alone on Mars, I mean, yes, as Mariah said, there's other rovers, but they're no longer working. I would think if you're lonely, that's a good way to sort of make yourself feel better about things. And hey, why not? If I'm Perseverance, why not happy birthday? And maybe Perseverance and Curiosity can wish each other happy birthday.
That would be awesome. Mariah, are there any backup cameras or instruments? So if something fails, is there a backup to it?
We have lots of cameras on the rover, and so if one fails for some reason, we're not completely blind. We've got other ones. We've got a lot of them that are used primarily for engineering purposes, for driving, for scoping out terrain and navigation purposes. And then we've got our science cameras, and so they each have kind of their unique purpose, but they all work together. And if one stopped working for some reason, we would have others that could take over. The other instruments, some of them we don't have backups for. The meteorological sensor, that's one that if that malfunctions, we're out of luck. And unfortunately, actually, one thing about the Curiosity landing was that part of the wind sensor on the Curiosity rover malfunctioned during the entry, descent, and landing. And so this was a situation where we had one of those instruments and we couldn't get it back. So we did our best to understand wind in other ways. But sometimes, there's only one and no backup.
If I could add to that, one of the things, big shout out to the engineers at JPL. It seems sometimes, something there's an anomaly within an instrument or some aspect of the rover, and you got to remember this thing is on another planet, and these folks are able, by and large, to troubleshoot and very often find ways around the problem such that the functionality of the rover is completely restored again. So, I totally agree with what Mariah said. I just want to say that I am astounded and impressed by the ability to troubleshoot and repair things that are located on the surface of another planet.
Kind of following up a little bit on that, Lucia and Ariana would like to know, how do we avoid introducing living organisms from Earth into the Martian soil and atmosphere?
Yes,
do that, Mariah, or go ahead.
I can start it off. That's a great question. This is what we call planetary protection, and there's a lot of work that goes into making sure the spacecraft is sterilized and everything is done in a clean environment out at JPL, so that we can't contaminate the spacecraft and send those microbes, any microbes from Earth, to Mars. So there's a lot that goes into making sure that everything is clean and sterilized before it launches off the surface.
All right, we've got Shaw Montessori Upper Elementary in Phoenix, Arizona, as well as homeschoolers in Wales and Walnut Grove Secondary School, all tuning in, as well as Egypt. Thank you all so much for watching. We've got just a few minutes left in this live chat. And then once we wrap up, the NASA TV coverage will start, and we really encourage you to watch that. We are at 1 hour and 55 minutes until touchdown. And so everybody around the museum, I know, is getting really, really excited about it. John, at the beginning of the show, you cut out a little bit, and I'd kind of like to loop back around because we did get another question about this. it's getting a little crowded around Mars. Can you tell us what's going on with the other missions?
Yeah, so there's a bunch of missions at Mars that are still operating. Some from the European Space Agency. There's a mission from India, and then of course some prior U.S.-led missions like the Odyssey spacecraft and the Mars Reconnaissance Orbiter spacecraft, etc. But the recent arrivals, just here in this sort of 10-day period, have been a new orbiter from the United Arab Emirates called HOPE. That will remain in an interesting orbit around Mars that allows it to do some up close and personal sometimes, but then sort of whole side of Mars observations at others to understand the atmosphere of Mars and how it's probably evolved over time. The Chinese have just had a lander orbiter combo arrive at Mars last week. That went into orbit and will eventually have its lander with a rover included detach and head down to the surface, and then of course Perseverance arriving here in just under 2 hours. The reason for that is that about every 26 months or so, the Mars and Earth planets do sort of a relative close approach, and we can take advantage of that to launch spacecraft with sort of a minimum amount of fuel and time needed to get to Mars. So last July, there was this sort of frenzy of activity to get all these missions off at about the same time. And then, of course, they all arrive at Mars at about the same time.
We still have a lot of people watching from all over. Delaware H.B. DuPont Middle School, Desert Shadows Elementary School in Scottsdale, Arizona, and Snowed in Missouri. This is an interesting question that came in. Someone would like to know, is Perseverance the last rover we'll be sending to Mars before we'll start sending people?
No. Because as Mariah, I think, really explained very well, Perseverance, in addition to looking for biosignatures, signs of life, understanding the geology of the Jezero crater landing site and beyond, is part of sample return. We're going to use the rover to cache samples that'll be left on the surface for a fetch rover to come on the next mission to the surface to pick up, that will then be launched back into orbit and eventually, we hope, return to Earth. So the next rover from the sort of US European side will in fact be, we hope, will be that fetch rover to pick up those samples. Other countries may be doing other things.
Awesome. Well, we're at 1 hour and 52 minutes until the landing on Mars. And Mariah, this next question, somebody wants to know, other than communicating back that we've landed safely, what are the first tasks for the rover?
Yeah, so I think as John mentioned earlier, there is a lot of work that goes in right after landing to checking out all of the instruments, making sure everything is working the way it should. We'll turn everything on, start doing diagnostic testing, start calibrating the instruments to work in the Martian environment, and all of that can take days or weeks. And so those will be kind of the first set of objectives for the team to accomplish. And then, as I mentioned, shortly after that, we will probably be setting the helicopter on the surface, and then start driving away and let the helicopter hopefully do its test flights. And then we will be on the road and we'll start exploring Jezero Crater.
John, how do we make decisions on where the rover goes every day? And I know that you've had some experience, and Mariah has as well. So do you want to tell us a little bit about, if you want to start, about how we make those decisions?
Yeah, so NASA has lots of acronyms, and so they come out in phrases like SOG chair or LTP. What are those things? Well, a SOG chair stands for SOWG, Science Operations Working Group. And that's basically the room full of scientists that sometimes resemble a herd of cats that all want to do something different with the rover on a different day. They've seen images come down. Their interests are such that they want to go to rock A where everybody else wants to go to rock B. And so there's a lot of discussion about should you go to A, should you go to B? And resources from the rover, how much time will that take to do it? And that SOG chair is the person that sort of herds those cats into a consensus that decides what's done with the rover on that given day. Now, the other side of that is the LTP, and that stands for long-term planner. And they take a longer look at things. They kind of not worried so much about what we're going to do today or tomorrow, but how what we do today or tomorrow might affect what we do over the next couple of months. And they're in the back of the room sort of poking the SOG chair on the back saying, hey, remember, we got to get over there here in the next week or two. And so it's a team effort. And I would point out that even though I kind of kiddingly described the scientists as a herd of cats, it's not that way at all. It really is a very congenial, very fascinating discussion that occurs, because you hear all of these inputs from all of these people that have different expertise, that have different perspectives on what they think is important and how that fits into the mission objectives. And so by having this process, as opposed to just focusing on one thing and one thing only, I think really leads to an enrichment of the science process and the science return from these missions.
All right, well, we are just about out of time. Mariah, I've got one more question from you that came in. Why do we need to study Mars?
An important question. One of the reasons that we really want to study Mars is because we know that Mars at one point in the past looked a lot more like Earth than it does today. So understanding why it changed, how did the climate change on Mars so much over the last couple billion years, really helps us kind of get at those questions about habitability and understanding solar system and planetary formation as a whole. I think that we often think that we sort of understand everything about planets, but before we ventured off into the solar system, Earth was one data point that we had. And so increasing our understanding of different planetary environments and geology on different planets, it helps us get kind of a more comprehensive understanding of these long-term processes that are guiding planetary evolution, and that help us understand where life could exist in our solar system and in other on other planets around other stars as well.
Awesome. Well, if you've enjoyed today's program, be sure to head over and give STEM in 30 a follow on social media.
We are produced by the National Air and Space Museum, and our goal is to take students to places and meet people virtually that they may never get a chance to meet otherwise. Here's a look at STEM in 30.
This is STEM in 30. But we're going to have you all create a little demo that you can take home tonight. We're going to do a little bit of math to figure out how far apart they actually are.
Here at the National Air and Space Museum, we supersized it, so we have got a really big model of the layers of the atmosphere.
It's only a failure if after it didn't work, you stop.
Nothing works the first time. You always have to be prepared for redesign.
My job is to stare out the window. You know how the teachers say you ain't gonna never learn anything staring out the window? I disagree.
We can share our passion for science and hopefully inspire them to do the same thing.
That's a good question. No, I did not.
Well, don't forget that we're just about out of time, but the coverage of the landing of Perseverance is just getting ready to start over on NASA TV.
Juntos Preservaremos, which translates to Together We Persevere, is NASA's first ever Spanish broadcast of a robotic landing on another planet. The 90-minute live stream will highlight the role that Hispanic NASA professionals have had in the success of NASA's Mars 2020 Perseverance mission, featuring interviews with Latino scientists and engineers as well as astronauts. The show will be hosted by Perseverance engineer Diana Trujillo and will include a children's segment in collaboration with Plaza Sésamo, live commentary of Perseverance's entry, descent, and landing, and other special guests. The show will air today starting at 2:30 p.m. Eastern on NASA en Español's social media accounts. The related hashtag is Juntos Preservaremos. STEM in 30 just released our latest episode focused on Mars. In it, you will meet planetary scientists and engineers working on the Mars rover. You'll also meet some amazing students and learn how you can participate at home with a great hands-on experiment. The next episode of STEM in 30 comes out on March 4th, and it's all about stealth. Have you ever wondered what's in the sky that you can't see? Learn about the secretive world of stealth aircraft. You'll explore the F-117 Nighthawk, the B-2 Spirit, and learn with hands-on experiments that show you how to avoid detection.
All right, well, be sure to head over to NASA TV to watch the landing. Fingers crossed for a safe landing.
Well, I will certainly sit through that 7 minutes of terror to see what happens.
Thanks, everybody, for watching.
Thanks for watching.